Alright, so this is a little bit of a strange substitution. If you have a look at u equals x minus x to the power of negative 1, we have du is equal to 1, and this will be minus minus, so plus x to the minus 2 dx. So you've got 1 plus 1 on x squared dx, which kind of doesn't look like what we're heading for over here. If I multiply both sides by x squared, this will be an x squared plus x squared on x squared, so that's 1 dx. Now that I've got at the top. So it's like we've started looking at the integral, and so this bit, this 1 plus x squared dx here, I'm going to replace. Even though I've got x's and du's, I'm going to replace like that, just to see what I've got so far. So I've got that. I'm not going to put any limits in because I'm mixing x's and u's, so I don't really want to put the limits in, although it does say du, so I could put the u limits in. Now that's x squared, actually, well, let's have a go at finding the limits. So these are the limits for dx, and say we want to make them du limits. So the bottom limits looks nice. So if we have x equals 1 and we put it in u, we've got u equals 1 minus 1 on 1, so we just get a 0 there. So we are going to go from a 0. A little bit trickier if for the next one. Here we've got x equals a half of root 6 plus root 2. Alright, so if I'm looking for u equals root 6 plus root 2 on 2, so that's the x. Take away 1 on that. So probably what I'll do is I'll just put it upside down. That's the same thing, the reciprocal, and I might rationalize that denominator just there. So timesing by root 6 minus root 2. And you can see that here we will get, I'm going to double this because I know I'm going to get a 6 here. I'm going to get 6 minus 2, which is 4. So I'm going to get a common denominator of 4. So if I double this, I can have a denominator of 4 underneath. Here, minus 2 lots of root 6 minus root 2's. Now, if you think about it, you've got 2 root 6's, take away 2 root 6's, so they cancel. 2 root 2's minus 2 root 2's. So we've got 4 root 2's there. I hope that makes sense. So we've got 4 root 2's on top over 4. So we're just going to get a root 2 as our other limit. So I'll put it up here. There we go. All right, but how are we going to get rid of these x values here? Something you might like to look at, because we know u is equal to x minus 1 on x. And when I do square that, I have a go at squaring that because it just looks like one of those questions. I would get x squared, so square the first term, square the last term, and double the product. Well, the product is 1, so double the product would be minus 2. So if I put that back as a u squared, so I'm going to get u squared plus 2 is equal to, so I've just moved that over to the other side. If I make a common denominator here, I'm going to get x to the power of 4 plus 1 on x squared. And that is what we've got, yay, that is what we've got here, but the reciprocal. So if I reciprocate, I'm going to get 1 on u squared plus 2 in my integral. Alright, so here we go. So now we've got it set up. It's supposed to make the integral easier, of course. So we're going from 0 to root 2. Now we've got du over, and now we've got u squared plus 2. Now, hopefully you recognize that as an inverse tan. So remember, inverse tan has the 1 on the a part, whatever. So here's this. This is root 2 squared. So I know it's 1 on root 2. So have a look at your formula booklet if you're not sure. And this will be u on root 2 here. So it's a definite integral between 0 and root 2. So I've got 1 on root 2. Here I've got inverse tan of root 2 on root 2 minus inverse tan of 0 on root 2, which is 0. So nice and easy. We know that's pi on 4. We know that's 0. So we've got pi on 4 root 2. If you want to, you could leave it like that, but if you want to rationalize it, I'll just go over here. what are we going to get? We're going to get root 2 pi on 4 2s are 8. And that would be your answer.